All right, guys, here is your first basic example using our new integration by parts formula. We have the integral of u dv equals uv minus the integral of v du, which I know makes almost no sense to you at the moment, but just try to think of this as this is basically our reverse product rule. So it takes our product rule when we have two functions multiplied together and allows us to actually go backwards. So what would an example look like? Well, let's say we've got the integral of x times sine x dx. So it'll be pretty obvious that product rule is involved. The difference here is like the problems we used to use like this. The problems we used to use like this, we'd have a u substitution somehow, right? But there's nothing you could possibly substitute here for a u substitution directly, but there are actually two functions that we could substitute for at once. So you need a u, right? We need a u and a dv to match our formula. So we have a u, and I'm going to put the dv down here because a u implies I'm going to need a du, and a dv implies I'm going to need a v. But these are the two I got to start with. So u I'm going to let be x, and dv I'm going to let be sine x dx. And now I have a perfect substitution. So u is my x, dv is my sine x dx, and before you ask, I already know what you want to say. What if I mix them up? What if I make this my u and this my dv? Well, if your next step doesn't get any easier than what you started with, then you obviously need to pick something different, kind of like when we do u sub. All right. So what does this look like when we split that up? We have x was u, so I'm sorry, x is u. We need du is dx, and if dv is sine x, well then v must be what, negative cosine x, right? So negative cosine x derivative would be sine x, and the derivative of x is just 1 dx. So I got to follow my formula, uv. uv is negative x cosine x minus the integral of v du, which is negative cosine x, and du is dx. Let's clean up the negatives. This is going to be negative x cosine x plus the integral of cosine x dx. And this is where you make that determination. Did you do the right thing? Looking at our rule, and then looking at what we actually have, I look at this integral and I say, all right, is that easier than what I had before? Well, what I had before was this. That wasn't easy. That's easy. I can do that one. If you end up with an actual like integral that you can't do, well then either you made a mistake going, with my u and my v, or you might just have to do something else. Maybe you just, maybe you made a mistake, or maybe you have to try again. All right, so let's finish it. We've got negative x cosine x. Integral for cosine is going to be sine. And now here at the last moment doing that integral, since it's indefinite, we do our plus c. There's no need to do the plus c on the first part or the second part. It's only when we do at the end, because we don't need to do like a c1 or a c2 or a c3. Just do the plus c at the end. So the integral of x sine x dx is going to be negative x cosine x plus sine x plus c. And that's how that works. So you got to substitute for u, substitute for dv, get all the pieces of the puzzle, and put the pieces back together. And then analyze where you're at after that first round. All right, hopefully that helps, and I will see you guys later.